Now, we are going to review the process of creating a confidence interval. The first interval we'll create is for an unknown population proportion, often called pi. A confidence interval will provide us with a range of values from which we can be fairly confident that our true population proportion will be captured. Let's think about this in a business setting. My idea for a new product is to develop a solar-powered charger for electronic devices. I plan to start out by selling the new charger at the local shopping center, but I want to make sure people will buy my product. So I went to the local shopping center first and randomly surveyed 400 people. The first question I asked them is whether they thought that this product was a product that they would consider purchasing. Using the data from that survey question, I can now estimate how many units of this product I could potentially sell. From my survey, I found that 50 people out of the 400 people surveyed expressed an interest in buying this product. We'll use this simple formula, x divided by n, to determine the sample proportion, often called p. Here, it would be 50 over 400, the 50 people that responded favorably over all of the people I surveyed. That works out to a 0.125 probability, or about 12.5%. This is almost all of the information that I need to create the interval, except for a confidence level. For this example, I will use 95%. This is traditionally the most popular level of confidence used in business. Here's the formula that we will use to create this interval. We first start out with a point estimate for this interval, which is the sample proportion written as p, as I mentioned, and sometimes it's written as p sub s. It should make sense that our sample proportion is our best estimate for the population proportion, which is usually written as pi. Our next key input is a z-value. Think about the second empirical rule that captured 95% of the data in a normally distributed data set. That z-value was about 2. Well, the exact z-value for a middle 95% works out to be 1.96. Traditionally, this is derived from the alpha value in the formula, which is the probability equal to 1 minus the level of confidence, or 1 minus 0.95, which leaves us with an alpha value of 0.05. Alpha becomes our tolerance level for making an error. This is why you'll often see the middle 95% shown as alpha divided by 2 in each tail, as you can see in this display. Finally, we need to take into account the sample size, or n, which you should know to be 400 for this interval. Now all that we have to do is plug the numbers in and work the interval out. So we start with our point estimate of 0.125, add and subtract 1.96 times a fairly complex square root of our sample proportion, 0.125, times 1 minus the 0.125, all over 400. After we work that out, we get an interval that starts with 0.0926. That will be less than the population proportion, the market share we hope to get, which is less than 0.1574. From this interval, we can state that we are 95% confident that our true population proportion of our target market would be between 9.26% and 15.74% for the new charger. Note the application of alpha in this context. Since in this example alpha was equal to 0.05, this means there is a 5% chance that the true population proportion pi is not contained in this interval. This leaves us with a fairly reasonably narrow range that we should be able to utilize to help estimate the number of people that are likely to purchase our product. In the next video, we'll go on to see what the price they are willing to pay.